Okay, in lesson 6.7, your class, we had finished A, B, and C, finding the inverse, and then also talking about whether or not that inverse was a function. And then, based on past years, I've skipped D and E and gone straight to F. And again, I think that's based on you can get by without D and E in homework. I'll have to double check that. So let's look at F. What is step 1 when we are trying to find an inverse? Switch X and Y. So instead of Y equals, I'm going to say X equals. Instead of 8X cubed minus 1, we're going to say 8Y cubed minus 1. After we switch X and Y, our job is to do what? Solve for Y, which means we are going to add 1. If it's 8y cubed minus 1, let's start by adding 1. If we add 1 on one side, add 1 on the other side. X plus 1 is X plus 1. 8y cubed minus 1 plus 1. 8y cubed. What's my next step in getting y by itself? Okay, if it's 8 times y cubed, let's divide by 8. If we divide one side by 8, divide the other side by 8. Now, 8y cubed divided by 8 is going to leave me with y cubed. X plus 1 divided by 8. You can leave it as x plus 1 divided by 8, which I think is what I'm going to do. I think that's what yeah. Or you can say x over 8 plus 1 over 8, which really is more than likely going to complicate things unless it's necessary for some reason. So let's say x plus 1 over 8. Okay. Am I done? Do I have y equals? Not quite. I have y cubed equals. How do I get y cubed to become y? Because it's a power of 3, you take the third root, which the cube root. If I take the cube root on the left, we take the cube root on the right. What is the cube root of y cubed? Y. What is the cube root of x plus 1 over 8? Okay. One option would be the cube root of x plus 1 over 8. Got another option for me? Jaden? Yeah, do we know the cube root of 8? Yes. The cube root of 8 is 2, yes? So, yes, leaving it as one big cube root with under the cube root being x plus 1 over 8 is an option. However, the other option is to say the cube root of x plus 1 over the cube root of 8, which the cube root of 8 is 2. Do I need a plus or minus here? No, because it's a cube root. Okay. No plus or minus because it's a cube root. It's an odd root. We only use the plus or minus when it's an even root. So, oops, I almost forgot. Instead of leaving it as y equals, I'm going to change it to f inverse of x equals cube root of x plus 1 over 2. And keep in mind, I'm not taking the cube root of x plus 1 because that's a sum, and I don't know the cube root of x. That plus 1 is being added, so I can't take the cube root of just the 1 because it's being added. So we're going to leave it as that. Now, the question that we were talking about yesterday, is it a function? Well, do you know anything about what this graph looks like? My guess is probably not. Okay, that wouldn't be my expectation. Okay, so at that point, start putting some values in. Okay, so if I just pick random values, if I put in 0 here, 0 plus 1 is 1. The cube root of 1 is 1 over 2. When I put in 0, can I get anything out other than the 1/2 that I just got? No, there's no plus or minus. I put in 0, I'm going to get a value out. Okay? If I put in any other number, if I put in, say, 1, 1 plus 1 is 2. The cube root of 2 is some decimal I don't know, divided by 2. Am I going to get anything else other than that number? Do you see the point I'm trying to make here? I put an x value in, I'm only going to get one y value out. If I'm putting one x value in and I'm only getting one y value out, does that lead you to believe it's a function? Yeah, because if you recall yesterday when we talked about functions, the x can never repeat. So if you put an x value in and you can get 2 answers out, that's a problem. But if you put one x value in and you get one y value out, then this is likely to be a function. Okay, so I know we talked about the graphs of some of them yesterday, but I also wanted to talk about one that I don't expect you to know the graph. Okay. Questions on that section? We did most of that section yesterday in your class. Switch x, y, solve for y, label as inverse. Good to go there? Okay. We need to look at the bottom section, which I feel like it's been forever just because of weather and all of that. But example 3 is about using composite functions. We did composite functions back in lesson 6.6. Is that when we did fog and Goff? Yes. So when I talk fog, like F composed with G, Goff, G composed with F, and whatever else you had to do, that's composite functions. So we're going to revisit that a little bit. With the idea, notice what it says here. If F and F inverse are inverse functions, so if they are truly inverse functions, then there are 2 things that will be true. And that is F inverse composed with F of x will always equal x. And F composed with F inverse of x will always equal x. So if a function and what we're claiming to say it's inverse are truly inverses, when we compose them, either way, it will always simplify to be x. And that is something you can use to prove, if you're given 2 functions and told that they are inverses, you can use to prove or disprove whether they're functions. So I'm going to walk you through this example here. So first of all, we're given the function f of x equals 5 minus 2x. Given, right? Part A says find f inverse. So if it says find f inverse, we're using the rules from above, right? Now, keep in mind, if it says f of x equals 5 minus 2x, what is f of x the same as? This is the same as saying y equals 5 minus 2x, correct? You need to know that if you see an f of x, oh, I can think y. Let me zoom in a little bit so you guys can see that better. Okay, so on part A, how do I find the inverse? Start by what? Taking x and y and switching. So instead of y equals, I'm going to say x equals. Instead of 5 minus 2x, I'm going to say 5 minus 2y. And now we need to solve for what? Y. So how do I start working to get that y by itself? It's 5 minus 2y. What do I have to move away first? The 5. How do you move a positive 5 away? You subtract 5. If I subtract 5 on one side, subtract 5 on the other side, So if we have x minus 5, that's going to be x minus 5. On the right, 5 minus 5 cancels, and we're left with negative 2y. How do I continue to get y by itself? If it's negative 2 times y, divide by negative 2. Now, keep in mind, you can divide the whole piece by negative 2 like that, or you can divide each part by negative 2. For what we're doing, I would say it's probably easiest to just leave it as one big fraction. Okay? So, negative 2's cancel. Y equals, I'm just going to write it as x minus 5 over negative 2. Officially, instead of saying y equals, how should I label that? Yeah, f inverse of x equals x minus 5 over negative 2. You guys see that? I kind of started to run out of room there. Whoops. Scoot it up. Make sure I'm above the glare for virtual. Hopefully. Okay, that was part A. Just find the inverse, right? Now, part B asks us to find, I can't really say FOF. It's f inverse composed with f of x. Do you remember how we did these compositions last week? If it was fog, we would have done f of g of x, right? So this means we're going to be doing f inverse composed with f of x means f inverse of f of x. Now, what if I tell you we already know the answer before we ever get started? We already know the answer, and we haven't even started. How do we already know the answer?
It's always x.
It's always x. What did it say up above in the directions? If a function and its inverse are composed, either order, it will equal the input, which in this case, my input is just x. Now, do I expect you to just put x right here?
Yes.
No, not on this one. We're learning here, okay? We're learning, and we have to. I want to show you that it works. I want to prove to you that it really does equal x, and not you just have to be, well, she said it equals x. I want to show it equals x, okay? So, and besides, I can guarantee you guys could handle some practice of compositions. So, f inverse of f of x means I'm going to take f of x, and I'm going to put it into f inverse, right? Now, I'm debating which way I should do this. Okay, so what is f of x? F of x was what? 5 minus 2x, right? That was in our directions. That was given. And what are we going to do? We're going to put that into f inverse. So one way to think about this is we're finding f inverse of 5 minus 2x, which means when I write out f inverse, every place I see x, I'm going to replace it with 5 minus 2x. So, what is f inverse? According to my previous problem, f inverse is something, can I say that? Something minus 5 divided by negative 2. Are you okay with that idea? F inverse is whatever x is, subtract 5, divide by negative 2. What am I putting in for x? 5 minus 2x. I'm trying to give you a visual here for those of you that are struggling with this concept, which is probably a good handful of you. Okay, I'm guessing there's definitely some struggles still. So I took f inverse of x, and I plugged in f of x. So I plugged in 5 minus 2x. Now, do some cleanup. In that numerator, I have 5 minus 2x minus 5. What's 5 minus 2x minus 5? Negative 2x, because what's going to happen? 5 minus 5 cancels. So I have negative 2x divided by negative 2. What is negative 2x divided by negative 2? X. What did we propose this answer was going to be? X. If we did it the other way around, okay, and we had done f of x of f inverse of x, so if we put f inverse in it to f, it would also simplify to be x. Okay, now C. Nice. I didn't even get to ask. We are going to work it out, but Dayton stole my answer there, or my question, without doing any work. What is f composed with f inverse of 2? 2. Because when you compose a function and its inverse, it's going to equal whatever the input is. What is the input in this case? 2. Now, let's prove it. Okay? So, f composed with f inverse means I'm doing f of f inverse of 2. Where do we start? Starting on the inside. So this time, f inverse of 2. What's f inverse of 2 mean I do? Put 2 into x of f inverse, right? What is f inverse? F inverse was x minus 5 divided by negative 2. So something minus 5 divided by negative 2. What's my something? 2. Okay, yeah, we have to talk fractions for a moment, but it's okay. So what is 2 minus 5? Negative 3. So now I have negative 3 over negative 2. What do you know about negative divided by a negative? It's a positive, yes? So can you handle me saying that 2 minus 5 over negative 2, negative 3 over